The electrode potential of the following cell at 298 Kelvin. At the anode, X is changing into X plus 2 and concentration of the X plus 2 ions is 0.001 moles per liter. And now this is the anode and this is the cathode. At the cathode, reduction is taking place. Y2 plus ion is changing into Y. Concentration of Y2 plus ion is 0.01 moles per liter. E cell you have to find out. Standard reduction potential values of X and Y are given. E naught cell will be equal to E cathode minus E anode. So E naught cathode is 0.36 minus in brackets E naught anode, which is minus 2.36. Solving, E naught cell is 2.72. The reaction at the anode is X changing into X plus 2 ion giving 2 electrons and the concentration of ion is 0.001 moles per liter. And at cathode, Y plus 2 is accepting 2 electrons and changing into Y, and concentration of the ion, that is Y plus 2 ion, is 0.01 mole per liter. Number of electrons lost is equal to number of electrons gained. Adding these two equations, this is the anode, it is the oxidation reaction, and at cathode it is the reduction reaction. Adding these two equations, electrons on both the sides get cancelled and you get this redox reaction. So E cell will be equal to E naught cell minus, now 2.303 RT by F is given as 0.06. So 0.06 divided by number of electrons. Now number of electrons participating in this redox reaction is 2. Log product divided by reactant. In the product, X plus 2 ion multiplied by Y divided by concentration of Y plus 2 ions multiplied by X. Now concentration of Y, since it is in its atomic state, will be taken as 1, X will be taken as 1. Putting the values of the concentration of the ions and E naught cell, the equation becomes E cell is equal to 2.72 minus 0.06 divided by 2 log 0.001 divided by 0.01. Now 0.001 divided by 0.01. This will be, removing the decimal, this will be into 100, this is into 1000, and 100 cancels and you get this as 1 by 10. So this will be log 10 to the power minus 1, which is equal to minus 1. So this whole value is equal to minus 1, and 0.06 divided by 2 will be equal to 0.03. Now 0.03 multiplied by log 0.001 divided by 0.01, that is minus 1. So 0.03 multiplied by minus 1 will be minus 0.03. Then again 2. So this becomes 2.72 minus 0.03, which will be equal to 2.72 plus 0.03, and this is equal to 2.75 volt, and this can also be written as 275 into 10 to the power minus 2 volt. So E cell will be equal to, here in the fill in the blanks, it will be 275 into 10 to the power minus 2 volt.